Hello, everybody. Welcome to General O'Clock. Today, we'll be talking a little bit more about global warming and why we need to worry about it more than we worry about the coronavirus. Now, we also need to talk about what scientists are doing to sort of address this problem, and so we won't focus more on bad news. So we'll give a little bit of good news too. But there's still a lot of work that still needs to be done there. But as a culture here, General Clock will highlight the author of the paper, where they are and where they've been. So the title of the paper here is a ruthenium porphyrin-based porous organic polymer for hydroxylative reduction of carbon dioxide to formate. Now, Soros McGregor did his bachelor's in chemistry in the University of South Carolina, went to do his PhD in Georgia Tech. He started his career as a postdoc in Northwestern University. He's currently a professor at The Ohio State University. Go Buckeyes! Global warming is a normal phenomenon. In actual fact, the Earth uses greenhouse gases to keep us warm. The way that it does this is through the sun. So the sun, what it does is that it gives off radiation that penetrates through the Earth. Obviously, some of that radiation is reflected back to our sphere or something like that. Now, the radiation that makes it through heats up a lot of things inside the surface of the Earth. That is your objects, rivers, human beings, animals, you, and stuff like this, right? And then what then happens is that these objects that are heated up, they sort of give off now radiation, what is now called black body radiation. But that radiation is more of a long wavelength kind of radiation. So that radiation is then absorbed by these greenhouse gases. Now, the reason why the initial radiation from the sun is not absorbed by these greenhouse gases is because the initial radiation is of shorter wavelength, right? And so it means they're high energy, right? So the greenhouse gases don't absorb in that region. They sort of absorb in the near infrared region. That is where now the other radiation that comes from the Earth lies upon, right? So that's why you get because the greenhouse gases still exist when the initial radiation passes. So it passes through, it doesn't get absorbed. But when it comes back, it has of a longer wavelength, which means it has lower energy. So then these greenhouse gases are able to absorb it and now keep us warm and heat us up. Now, this is all good and well, right? This is great. This is how nature does this thing, right? But then because of industrialization and irresponsibility from our part, we have offset this balance that nature has set up here. Right now, we have cars that release a lot of carbon dioxide, and we release methane, nitrous oxide, and all of those things. Right, so we now have offset that balance. So now the planet is heating up in a manner that it is not desirable. Right, so we ought to find ways in which now we address that. Right now, carbon dioxide is a major culprit here, right? Because if you think about it, anything like steam engines, your electricity, your car produces carbon dioxide, you producing carbon dioxide, and a lot of this, right? So, as mentioned, the high levels of carbon dioxide in the atmosphere is a result of burning of fossil fuels and all other things that contribute to the escalating levels of carbon dioxide in the atmosphere. Now, nature has a way to address this problem through a phenomenon called, or through a process rather, called photosynthesis. Now, this is a perfect system. In the case where there's high levels of carbon dioxide, even if there's no high levels of carbon dioxide in the atmosphere, but there is a way to absorb that carbon dioxide and convert it into oxygen, which is what we need to breathe, right? So this is a perfect system. So to sort of keep the balance going in the case where there's excess carbon dioxide or there's carbon dioxide in the atmosphere at all. Now, the challenge here is that we as humans have found a way to defeat that, right? So we have because we want trees, we want to build houses, we want to set fire and all of this to keep ourselves warm. There is high levels of deforestation, right? Now, because of this, the process of photosynthesis is not effective because you don't have enough trees to be able to sort of balance the level of carbon dioxide that's in the atmosphere. So now the planet keeps on heating up, obviously now resulting into rising sea levels and all of those things, right? Now, it's not all bad news, right? So there is research and some really, really good materials that are out there now that are doing really, really well. So these are your metallo-organic frameworks. These materials are able to absorb carbon dioxide like in really, really competitive numbers. There are also your covalent organic frameworks, which also do the same thing as metallo-organic frameworks, even much better covalent organic frameworks because they are light materials, they have no metals in them, so they are really, really good. Another one is the porous organic polymers, which also are very good at also absorbing gaseous molecules. Now, how do these molecules work or these materials work? So the way that they work like your sponge in the kitchen. I'm sure everybody has a sponge in the kitchen. The way that it absorbs water absorbs carbon dioxide rather, the same way your sponge would absorb water, right? Now, this will be more like a realistic picture of how it looks like, right? So in the walls there, that is where the carbon dioxide molecules are packed inside those walls, and some of them are in the nodes there. So, but they pack. This is a really, really, really big molecule in terms of surface area, right? So the highest surface area reported for the highest COF, a covalent organic framework, is about 5,083 meters squared per gram. That is about the size of a football stadium, right? That means that for 1 gram of that material or that COF, you can spread it so that it covers the entire football field. That is powerful. I think that is really, really powerful, right? That means that 1 gram of this material can pack carbon dioxide molecules equivalent to a football stadium. That is massive, right? Just 1 gram, and 1 gram is like the size, like a quarter of a teaspoon or something like that, right? It's a really, really small amount for a football field. And you can't comprehend in your mind as to how this would work, but that's how it is, right? That's how it is. That's how it has been tested. It does this, right? So these materials are really, really excellent materials now. So they actually absorb this carbon dioxide. Actually, NASA is invested in these materials to sort of absorb carbon dioxide and stuff like this, and sort of keep it. Now the big question then